Hey guys, so welcome back to SlideHunt with another video tutorial on data structures. SlideHunt provides free video tutorials. To get the complete series of data structure video, please subscribe this channel by clicking on the subscribe button that appear at bottom right corner. Or you can visit my channel by typing www.youtube.com/SlideHunt. Okay, let's back to our topic. So far in this series, we have learned different types of data structures. As we know, there are two types of data structures. One is linear and another is non-linear. We have talked about different linear data structures such as array, linked list, stack, and queue. We have talked about tree also. Tree is a nonlinear data structure. As we know, data structure is used to organize data in a specific order. For different data, we need different data structure. In this lesson, we will learn another nonlinear data structure is called graph. In computer science, graph has many applications. Here in this lesson, we will learn graph as logical or mathematical model. Okay, now we start today's lesson. But before that, I wanna tell you something. I opened another YouTube channel named SlideHunt Art. This is basically an art and craft channel. If you are interested, please visit the channel and subscribe it. I put the link in the video description below. Okay, now back to our lesson. Here we draw two nonlinear data structures, one is tree and another is graph. Similar to tree, graph contains some nodes called vertices, and vertices are connected to each other through a set of links called edges. Here nodes or vertices are represented by circle and edges are represented by a line or line segment. In a tree, nodes are connected to each other using some rules. They cannot be connected any arbitrary order. A tree with n nodes must have exactly n-1 edges. Each edge represents a parent-child relationship. Here you can see this tree has 7 nodes. So number of edges will be 7 minus 1, that is 6. Let's count the edges. 1, 2, 3, 4, 5 and 6. So this rule is satisfied. A tree with n nodes have exactly n-1 edges. But in case of a graph, there is no rules. Nodes are connected to each other any order. So we can say tree is a special kind of graph, or we can define it as a circular connected graph. Here we learned about some basic things about a graph. But what is its actual definition? A graph G equal to V consists of an ordered pair of a set of vertices V and a set of edges E. Ordered pair means a pair of mathematical objects or elements in which the order is important. For a graph, an ordered pair can be written as something like this, within parentheses V, E. Here objects are separated by a comma. Here V is the first object or a set of objects and E is the second object or set of objects. For a graph, first object always be a vertex and second object must be an edge. That's why we called it is an ordered pair. But for an unordered pair, order is not important. Objects can be arranged in any order. For a set of two objects V1 and U1, we can write it as either U1 V1 or V1 U1. Both are same because here order is not important. Here you can see I have drawn a graph with 7 vertices and 8 edges. So we can write V equal to V1, V2, V3 up to V7. Now what is the set of edges? Before answering this question, we have to know how to represent an edge. An edge is identified by its two endpoints with a unique pair of nodes. Means we write the two endpoints in a pair. For example, we can represent this edge as v4, v5. Since vertex v4 and v5 are the two endpoints of this edge. But edges can be of two types. One is directed edge and another is undirected edge. In case of directed edge, connection is unidirectional or one-way, and in case of undirected edge, connection is two-way or bidirectional. Here with the edge of unidirectional, we can say there is a link or path from the vertex u to v. Since the connection is one way, we can't assume there is a path from vertex v to u. For a directed edge, one vertex can be named as source and another vertex can be named as destination. And we draw the edge as arrowhead pointing towards the destination. Here u is the source and v is the destination. A directed edge can be represented by ordered pairs something like this, u, v. In the pair, first element always be source and second element must be destination. This pair indicates there is a connection from vertex u to v. But we can't write the ordered pair as v, u because there is no connection from vertex v to u. Here I am going to draw a directed edge from vertex v to u. Now we can represent this edge as v, u. But in case of undirected edges, connection is two-way and there is no source and no destination. An undirected edge can be represented by unordered pair. We can represent the edge as either uv or vu, both are same. Now look at the graph that I draw here. Here all the edges are undirected. Let's represent these edges. For this edge, we can write it as v1, v2. For this edge, v2, v4. For this edge, v4, v5. Same way, we can represent all the other edges. A graph with directed edges is called directed graph or digraph. And a graph without any directed edges is called undirected graph. In directed graph, edges are unidirectional or ordered pair, and in undirected graph, edges are bidirectional or unordered pair. Next, we learn application of graph. Graph has many real-life examples. Graph can be used to model many types of relations and processes in physical, biological, and information system. Many practical problems can be represented by graph. Let's see some example. A social networking site like Facebook, Twitter, or Google Plus can be represented as an undirected graph. A user would be a node or vertex in the graph. And if two users are friends, then there is an edge connecting them. Similarly, friend suggestion also uses graph theory concept. Social network is an undirected graph because friendship is a mutual relationship. If you are my friend, I am also your friend. So the connection is two-way. Next example is interrelated web pages. The link structure of a website can be represented by a directed graph in which the vertices represent web pages and directed edges represent links from one page to another. In this picture, page A contains the link of page C. If we click on that link, we can jump from page A to page C. But we can't go from page C to page A, because C doesn't contain the link of page A. Now look at the page B and E. Page B contains the link of page E and page E contains the link of page B. It is also possible a page contains the link of itself. Here page F contains the link itself. If we click on that link, we come back to the same page. Another real-life example is transportation networks. In road networks, vertices are represented as various locations and roads are represented as edges. Graph theory is used to find shortest path between two nodes. Here I draw our intercity road network. Different cities are represented as vertices and the distance between two cities represented by edges. This is an undirected graph and the communication is two-way. Now I'm gonna assign some weights that represent the distance between two cities in kilometers. Now it is a weighted graph. So our intercity road network is a weighted undirected graph. As you can see here, to go from one city to another, a list of possible ways are available. But we have to find the shortest path to go from one city to another. For example, we want to go from city A to city E. You can see here, 3 paths are available to go from city A to city E. Here we use 3 different colors to show 3 different paths. Now you have to find the shortest path. Total distance of green path is 125 kilometers. Total distance of black path is 100 kilometers. And total distance of blue path is 120 kilometers. Black color path represents the shortest distance. So this is the best way to go from city A to city E. Graph 3 is also used to study molecules in chemistry and physics. Vertices represent atoms and edges represent bond between molecules. So this was about introduction to graph. Next tutorial we will learn properties of graph. Thank you for watching. If you like this video, please try it, hit the like button and leave a comment in the comment box. I'll be back with another tutorial. Till then, take care and keep learning.